Arrcus Proof of Concept presentation at ONUC Fall 2021. In this session, we present you the Arrcus Connected Edge platform to support the transformation happening in various verticals, industry verticals, as they deploy distributed application infrastructure. As part of this presentation, we have few slides to walk through the dynamics in the market, especially with the ongoing pandemic, and introduction to the Connected Edge platform with use cases. Following that is a short demo showing the edge interconnect between an on-premise edge site with the cloud providers to demonstrate a hybrid cloud routing fabric. The transformation that we are witnessing now is like a third wave of application landscape transformation. Mid-2000 was all about virtualizing the data center into private cloud for hosting the client-server applications, the three-tier stack, to be deployed and managed across multiple data centers. And about a decade ago, public cloud infrastructure started gaining traction with Amazon AWS, Microsoft Azure, Google Cloud Platform, providing a hosted infrastructure for the same three-tier applications to be in public cloud as well as in private cloud. The third wave is upon us now with the prevalence of the multi-cloud and 5G mobile connectivity models gaining traction, especially for the low latency support, high bandwidth, and secure network slicing. Today's distributed application needs to be closer to the edge so that the user's demographics, machines, sensors, all can avoid the round trips to reach the data center or the cloud, and be able to support fast rollouts of new applications and take advantage of the communication service providers providing compute infrastructure closer to where they are. So when you look at how the industries are adopting it and why edge networking is important and why Arrcus plays a critical role there, the third wave of distributed application transformation at the edge locations is actively adopted by different industry verticals. Retail enterprises are transforming the remote locations into edge locations with local compute to enhance the omnichannel experience, especially the curbside type pickup during these pandemic times, and deploy applications faster for the store associates to serve the shoppers better. Similarly, if you notice, the financial services market are deploying more edge applications for banking and trading right at the locations where the users are there. And then the industry factory automation are providing more of the sensors and the sensor networks with factory automation, robotics, and few other networks that are built in. Similarly, the content and the media is deploying low latency applications for the regional edge locations. In all this, the underlying network need to be extensible, operationally simple, and has to scale to meet the demands of the edge networks. So, and with that, we want to introduce the Arrcus Connected Edge platform as a hyperscale networking fabric to interconnect the data center core to the edge with the 5G and the service provider networks and the cloud provider networks. Arrcus ACE is a software platform built on the proven Arrcus operating system that run on white box general purpose hardware, and also to support the form factors like the virtual machines and also as containers. The Arrcus is modular, decomposable operating system with carrier class scale and performance. This BGP-centric architecture can support the requirements of a complex data center end-to-end, and as well as the service provider networks with virtualized distributed routing, and also some of the smaller edge locations that needs a campus-type switch or a router. The disaggregated hyperscale routing software has a very deep integration between the underlay layers as well as the platforms for the higher layers for application connectivity in the form of Arc-Edge. And the entire architecture is built as an API-first architecture with deep integration for analytics, visibility, and observability. Now, if you think in terms of the platform edge use cases, Arrcus with all the capabilities provides a modern underlay network fabric that works as a disaggregated software to run on any white box hardware. While Arrcus provides a solid underlay, for the application connectivity, the ACE platform has the Arc-Edge software to interconnect the compute infrastructure in the cloud providers as well as the multi-edge compute layers in the telecommunication service providers. Arcedge built with Arrcus can be deployed as an enterprise edge for on-premise network locations, as well as a 5G edge in the telecommunications network as a managed infrastructure, and in the public cloud providers like Azure, Google Cloud as cloud edges. Arrcus and Arcedges can be deployed, managed, and automated with Arc Orchestrator that supports OpenConfig and models and Terraform frameworks. And for the visibility and analytics, ArcIQ provides the telemetry-based monitoring and management capabilities. So all in all, Arrcus is a modern networking platform purpose-built to support the convergence of compute and communication layer happening at the edge.
You can see the ArcEdge instance is now in AWS, and let's copy the IP address. Let's SSH into the instance and log into the ArcOS CLI. We can look into the configuration to see it is similar to the ArcEdge Spoke instance at the remote site we did in the previous step. Swap 1 interface is a default next hop for all workloads residing in the AWS private subnet. Swap 2 interface is a tunnel interface. A static default route is configured to point to the tunnel interface swap 2. The username and password to connect to the ArcEdge Hub instance is also configured. Let's verify the connectivity by pinging the ArcEdge Hub. We can see the IP address that was auto-assigned to the swap 2 interface. We can also see that all traffic from the spoke is now routed through the ArcEdge Hub to the internet. With ArcEdge running ArcOS underneath, you are able to leverage the full routing capabilities of ArcOS. This allows users to utilize dynamic routing protocols such as BGP, OSPF, and ISIS to be configured on top of the overlay network, as well as security features such as ACLs that can be applied at a workload level. In this segment, we will show that traffic from the on-premise workloads at the remote site will go over the overlay network through the ArcEdge Spoke instances and the ArcEdge Hub instance. On the left side of the screen are the Ubuntu workloads in AWS. On the right side of the screen are the Ubuntu workloads in the on-prem remote site. You can see that the workloads in AWS and the remote site have the same overlapping IP addresses. We can also show that we have IP connectivity from the AWS workload to both workloads in the on-prem remote site. Let's log into the AWS workload. Let's ping the first workload. Now let's ping the second workload. The entire deployment in AWS can also be deployed using Arc Orchestrator's GUI. In summary, use Arrcus MCN to build flexible routing-centric hybrid cloud networks, orchestrate and automate your network at scale, and deploy multi-cloud seamlessly across on-prem, edge, and cloud providers of your choice.